Okay, question number 6 uses transformations, and I've got my transformation grid there and ready and available for me. Okay, so we've got this transformation matrix, and this transformation matrix appears here on the left-hand side of my table, and I read it as I see it. Okay, describe the transformations. I think the 3 is going to be 1, the half is going to be 2, the negative is going to be 3, 4, and 5. So I think I have 5 transformations, and I'm going to do DRT, dilations, reflections, translations. So a 3 in that position is having an A in that position, which is a dilation by a factor of A from the y-axis, therefore a dilation by a factor of 3 from the y-axis. A half in this position is like having 1 on A in that position there, therefore it's a dilation factor of 1 on A from the x-axis, dilate by a half from the x-axis. The negative in that position is having a negative there, therefore it's a reflection about the x-axis. Having a 2 there is like having an A there, which is a translation A units to the right. So translation 2 units, right? And having a negative 1 there is like having an A there, so it's a translation up negative, so therefore it's a translation down 1 unit. Okay, that's how I'm going to read my table. I get my words that I'm describing it from this column, but I was given a transformation matrix, so therefore I'm going to use this column. Okay, state the image 3, 6 in the transformation of 2. Now I can do it a couple of ways. I can multiply the matrix out and go 3, 0, 0, negative a half, put a 3 there and a 6 there, plus 2, negative 1, which is 3 times 3 is 9 plus 2, and minus a half times 6 is minus 3, minus 1 gives me 11 and negative 4, therefore the image is 11, negative 4. Or I can multiply the matrix out and say that x dash equals 3x plus 2 and y dash equals negative a half y minus 1. Therefore, the image of x will be 3 times the original of x, 3 plus 2, which is 11, and y dash is going to be negative a half times y, which was 6, minus 1, which gives you negative 4. Same answers. And lastly, state the equation of the image. Okay, so when I multiplied the matrix out, I got x dash equaled 3x plus 2 and y dash equaled negative a half y minus 1. I'm going to rearrange this for x. So x dash minus 2 all over 3 is equal to x, and y dash plus 1 multiplied by negative 2 will give me y. So my original was y equals x minus 2 squared plus 1, and I'm going to replace y with that and x with that. So I get minus 2 y dash plus 1 equals x dash minus 2 on 3 minus 2 squared plus 1, which gives me y dash plus 1 equals negative a half squared minus a half. The negative 2 will be a division and a division of both of them. And here I'm going to put this all over 3, which gives me x dash minus 2 minus 6. So I've got y dash equals negative a half x dash minus 8 on 3 squared minus 3 on 2, which you could leave like that. I could also write it as minus a half x dash minus 8 squared on 9 minus 3 on 2, which gives me minus 1 on 18, x dash minus 8 squared minus 3 on 2. All of them are good examples. I probably prefer this one, only in that I can clearly see that my turning point is at 8 and minus 3 on 2.